I'm Anil Kumar, sharing with you some application questions on derivatives. Here are a few questions on optimization. You can pause the video, copy these questions one by one. I'll also provide you with their solutions in following videos. Here's the first one, which is find the number which exceeds its square by the greatest amount. Question number 2 is, a fireman has to reach a burning building. Determine the length of the shortest ladder that will reach over a 2-meter high fence to the burning building, which is 1 meter behind the fence. Question number 3 is, a man in a boat at a location 5 miles from the nearest point on the straight beach wishes to reach a place 5 miles along the shore from that point in the shortest possible time. If he can row at a rate of 4 miles per hour and run 6 miles per hour, where should he land? Question number 4 is, the stiffness of a rectangular beam is proportional to the product of its width and cube of its depth. Find the dimensions of the stiffest beam that can be cut from a wood log of diameter 15 inches. Question number 5 is, in the planning of a restaurant, it is estimated that if there are seats for 40 to 80 people, the weekly profit will be $8 per place. However, if the seating capacity goes over 80, the weekly profit of each seat will be decreased by 4 cents times the number of seats above 80. What should be the seating capacity in order to yield the greatest weekly profit? And here is the last question, question number 6. A 20,000 meter cube rectangular cistern is to be made from reinforced concrete so that the interior length will be twice the height. If the cost is $40 per meter square for the base, $100 per meter square for the side walls, and $200 per meter square for the roof, then find the interior dimensions correct to one decimal place. That will keep the cost to a minimum. To protect the water table, the building code specifies that no excavation can be more than 22 meters in depth. It also specifies that all cisterns must be at least 1 meter in depth. So I hope you got all the 6 questions. You can pause the video, copy these questions and solve them. I'll provide you with their solutions and give you the link. Here is the solution for the very first one. It says, find the number that exceeds its square by the greatest amount. So we say let the number be x, right? Let the number be x. So the number has to exceed its square by the greatest amount. That means the difference has to be maximized, right? So we need to maximize difference, right? So let the difference d be equals to x, so that find the number that exceeds its square. So number exceeds, so that means x minus its square means x square. You get the idea. So the difference is x minus x square, and we need to maximize this. You need to maximize this. So that is how you can understand the question. Now, to maximize, what you should do, you find derivative of this difference, equate it to 0, find the critical point, right? I hope the steps are clear. So let's find the derivative of this difference. Let me do it here. With respect to the number x, it could be any number, right? So we get derivative of x is 1 minus 2x. So that is the derivative, and this derivative should be equal to 0 for the critical number. So when you solve this, you get 2x equals to 1, or x is equals to half, right? So that is what is your critical number. So we can say that the critical number for us is x equals to half. Now how do you know that this indeed will maximize the difference, right? So that is what we need to know. So what we can do here is we can analyze the critical number. So let's analyze the critical number. That means we'll analyze dt of dx. Critical number is half for us. So you can take a number which is less than this. So if I take a number which is, let us say, 1/4, right? So if I take a number which is 1/4, which will be half of this, right? And if I have to take a bigger number, it could be 1, right? So 1 is larger than half. Let us test the value. So the expression is d dash for 1/4 will be equal to, we can substitute 1/4 here. So we get 1 minus 2 times 1/4, right? So 1 minus 2 times 1/4 is half, which is positive. Since it is positive, in this interval, the derivative, that means the rate of change, is increasing, right? It is increasing. Now if I test the value at 1, right, this is the derivative, correct? This is what we are testing. Then be 1 minus 2, right, times 1. So that is -1. It is negative, more important. It could be any number greater than half. It will result into negative. So on this side we get negative, on this side we get positive. So negative means going downwards, right? So if you sketch like this, you know very clearly at half we have maximum. Is that okay? So that is what is important to show. And now we can write down the answer. That is, the number x is equals to half, right? So I hope these steps help you to do most of the questions which are based on optimization. Thank you and all the best.